Hey everybody, this is the video for April 15th. If you are watching this, I've already uploaded it to the classroom and hopefully you've turned in your homework assignment or even your notes as well on the Google Doc for April 14th. Please remember that it's really important that you upload those in a timely manner so then I can give you guys the answers back to your homework so you can kind of gauge whether you're doing well or you need help. And again, reach out to me if you do need a little bit of help. So what we're going to do today is we're going to kind of continue with sequences, but we're going to look at a very special sequence called an arithmetic sequence. Some people might call it an arithmetic or something, but I just call it arithmetic because how I pronounce it. So an arithmetic sequence. Now, there's a formal definition, but I'm not going to have you guys write that down. Again, please take out a brand new sheet of paper and label it 415 for your notes and the homework assignment. So what it basically is, it's a pattern where you're just going to add, or subtract, but we'll talk about what that would really mean, a constant value each time. So basically add the same number each time. Now I like to focus on just add because subtraction is a form of addition, which I'll talk about here in just a second. So you guys, these are two examples of arithmetic sequences. So when you look at this pattern, honestly, this might be something that you would see, except for maybe the negative numbers, in an elementary class. Because you would see the pattern is add 5, add 5, add 5, add 5. So to me, the pattern is add 5. That makes that an arithmetic sequence. Now, why can minus also be an arithmetic sequence? Because minus 3, minus 3, minus 3, minus 3. But again, we like to focus on the fact that it is addition. So what could we say? And remember, you can pause at any time to see if you know what's going to come up. But what's the same thing as minusing 3 each time is add negative 3 each time. Plus a negative is the same thing as minus. So whenever you see in a sequence that you think is minus a number each time, it's going to benefit you to think that it's addition of a negative number. Now, why is that so important is this number 5 or this number negative 3 is going to mean something in our formula so we can write our rule or our equation for arithmetic sequences. So you guys, the formula that you need to know for an arithmetic sequence is a sub n is equal to a sub 1 plus quantity n minus 1 times d. Now, just so you know, this d is going to be distributed here. I don't know why they put it after it. It would have been maybe nicer if they put it before it, but this is the way the formula is already written. But we do need to know what a few of these terms are. So whenever we're writing our rule for a sub n, well, a sub 1 is the first term. So we can say where a sub 1 is the first term of the sequence. So you guys, that would just be the first number in the pattern. N represents our variable because it goes with this. So if we want to find the 29th term, it'd be a sub 29. Then we would plug in something for n, but otherwise that'll stay a variable. But D represents, or D is the common difference. Now, whenever we hear the word difference, we normally think about subtraction. Well, if you look at that, that is how you actually get these important numbers right here. You take the number or the term and you minus it, what's in front of it, and that will give you the number 5 for the sequence. Notice, if I start at 14 and I minus the number in front of it, 14 minus 9 is 5. If I start at 19 and I minus the number in front of it, the difference is 5, and that's the same difference. So in order to get this number right here, you can take any number in your sequence and minus the term before it, and that will give you that. So same thing whenever you end up adding a negative. This right here would be considered the common difference. You could start simply with any term you wanted, minus what was in front of it. And 1 take away 4 is equal to negative 3, which is the pattern of add negative 3. So you guys, D is the common difference because you can get the number that you're adding each time by subtracting a term with what's in front of it or the previous term. All right, you guys, so this though is the key. We got to make sure that we understand this formula works for every single arithmetic sequence. Now we're going to see how we can actually use that formula to help us out. So we got 4 examples that we're going to do for our notes. Then you're going to have 4 homework problems. And again, hopefully you will do this and submit your Google Doc before 7 a.m. on April 16th so you can get full participation credit. Let me know if there's any issues that you're having or whatever. All right, so you guys, number 1, we are going to find the 65th term for -6, -4, -2, 0, 2, 4. So you guys, whenever you look at that problem, here's what I don't want you to do. I would not want you to write down 65 numbers in the sequence and then box the 65th term, because that's what it really is. What we want to do is we want to realize, hey, there's probably a shorter way of doing this. We want to write the rule. Because if we write the rule, then I can find the 65th term by simply plugging in 65 to that rule or that formula or that equation. So I look at it and I'm like, okay, well, how do I figure out how to write an equation or the rule for a sequence? Is I just learned about an arithmetic sequence. Now, what is the pattern that you see? The pattern is add 2 each time. So since the pattern is add 2, I can kind of confirm that would be my common difference. Well, the first thing I notice is it is definitely arithmetic. And then I actually know a few key pieces about it. I know a sub 1, or the first term, is -6. But I do need that common difference if you're looking at that formula. Now, what I already know the pattern is add 2. So 2 is the common difference. But I can get that by simply subtracting a number with what's in front of it. So if I start with -4 and I minus what's in front of it, -4 minus the term in front of it, well, minus a negative becomes plus, and -4 plus 6 is 2. So the common difference is 2. Now this is the information that I need to write the rule. I can simply write down the formula that's given to me. A sub n equals a sub 1 plus quantity n minus 1 times d. And I can plug in the pieces that I know. My rule would be a sub n is equal to, well, a sub 1 is the first term, plus quantity n minus 1. N stays a variable, remember, whenever we're writing the equation or the formula or the rule. And the common difference is add 2 each time, or 2. Now, as I said earlier, this will have to get distributed into both of those. So I have a sub n is equal to -6 plus 2n minus 2. And I will combine my terms for a sub n is equal to 2n. I like to start with my variable piece, minus 8. Now, this is not my final answer, but it's pretty important. That is the rule, and the rule will find any term. So if you remember yesterday, we could use the rule to find the first 6 terms or whatever, but you could do it to find the 65th term. So to finish out this problem, all you have to basically do is do a sub 65, which represents the 65th term, and that means you plug 65 into the variable. So it's 2 times 65 minus 8. 2 times 65 is 130, minus 8 is 122. So you guys, you could either box it like this, because if you understand notation format, we know that that little subscript of 65 represents the 65th term. Or you can write it out as the 65th term is 122. And then you didn't have to go through and write 65 numbers in that sequence. All right, so that's why the formula can be important and how it can help you out. Now, the next couple of things we're going to do is figure out how that formula can be manipulated with some different given information. So number 2, we are going to find a sub 37. Now, whenever we find a sub 37, that means the 37th number in the sequence. And we're going to be given if a sub 1 is 5 and the common difference is -3. Now, in all reality, this is actually just an easier version of what I just gave you. You did not have to know that it was arithmetic. We're obviously giving you that information. You didn't have to pick out the first term that's given to you, and you didn't have to see that the pattern was add -3 each time. We gave you the common difference. So this is really the same exact problem. So I'm going to go pretty quick through this. I would set up my formula. A sub n equals a sub 1 plus quantity n minus 1 times the difference. I would plug in my a sub 1 and my common difference. A sub n equals 5 plus quantity n minus 1 times -3. I always distribute my common difference. A sub n is equal to 5 minus 3n plus 3. Combine like terms, and I prefer to put my variable first. So -3n plus 8. Now the formula or the equation or the rule is not your final answer. We want to find the 37th term. So using this rule, I could do a sub 37 is equal to -3 times 37 plus 8, which gives me a final answer of -103. And I used my calculator for that. So the 37th term is -103. All right, keeping with kind of that format, we're going to be giving you information. Number 3, we are going to find a sub 1, or our first term in the sequence, if a sub 30 is equal to 93, and the common difference is 3. Now here's what we don't want you to do. This is a way to do it. You literally could put 93 here. And if we know the common difference is 3, that means that's the number we're going to add each time. So again, this is in the 30th spot. So I'm just going to put 30th slot. And we know that we could add 3 to get 96, add 3 to get 99, so on and so forth. Well, if you really had to find the first term, you could go backwards. And if the pattern is add 3, in order to go backwards, you do the opposite of that, -3. And then you go, okay, well, the 29th term is -390. The 28th term is -387. And what we don't want to do is we don't want to keep minusing the same number. Now, you might have figured out a shortcut of how you can get to the first number by using this kind of logic. But the easiest way is actually to use the formula, because the formula deals with all these. The hardest part is understanding how to plug this information in right here. So I'm going to kind of key on that. But I'm going to start with my formula for an arithmetic sequence. It's a sub n is equal to a sub 1 plus quantity n minus 1 times d. Now I know I'm finding a sub 1, so that's going to stay a variable. But what I have to do is figure out, well, where do those other numbers go? And this again is the hardest one. Well, when you look at it, the formula is a sub n. So 30 has to represent n. So I'm going to plug 30 into my n spot, minus 1, and the difference is 3. And then remember that overall this represents the term. So 93 takes the spot of the quote-unquote answer. Now that we have our formula set up with all the numbers plugged in, it would be 93 is equal to a sub 1 plus 29 times 3, sorry, just so I don't have to thank you guys, I already did it in my calculator, is 87. And then when you minus 87 on both sides, you get 6 is the first term. So if we were to start at 93 and take away 3, take away 3, take away 3, take away 3, until you get to the first term, you would get 6. But this is the way that we would like you to do it. You might have figured out another little logic way about how many times you have to minus 3. So then you maybe just did 93 take away a number, but in all reality, if you would have done that, 29 times 3, that's what that information is. And when you would have done 93 take away 87, that's exactly what we did in the formula. We're trying to learn how to use formulas a little bit better. So if you did it logically, that's great, but try to actually plug pieces in where they should go, because whenever we encounter problems that we can't do by logic, we need to be able to use the formula. All right, last problem of your notes. Sorry, that was number 3, by the way, so I'll put a 3 there. Is number 4. And we're going to find D, or the common difference, if a sub 18 equals 92 and a sub 1 equals negative 27. So what we really have now is we have the 18th term and the first term. But this is going to be the weird one for people to plug in to the formula. We'll start with our formula though. A sub n is equal to a sub 1 plus quantity n minus 1 times d. Now, I hope you realize this one is easy to plug in. Negative 27 gets plugged into your a sub 1 spot. But whenever you have something other than the first term, you have to know where the subscript goes and where the answer goes. The subscript gets plugged into n because it's the 18th term. And then the overall answer gets plugged into all of a sub n. So I'm going to plug in 92 is equal to negative 27 plus quantity. N is 18, take away 1 times d. So now I have 92 equals negative 27 plus 17d. I'm going to add 27 on both sides. For 117 equals 17d. And when I divide that, I don't even know if it works. It's 119, sorry. So when I divide that, it's going to be 7 is equal to d, or my common difference. Now, that's pretty much all we're going to do today. We're trying to learn arithmetic sequences. We're trying to learn how to use the formula a sub n equals a sub 1 plus quantity n minus 1 times d. Can be a little bit challenging at first, but if you do your practice problems and then you check the homework key that I'll be giving out the next day. So again, by 4/16 or April 16th at 7 a.m., the homework would be due, so then you can check your homework and see what you need help on. It's going to be hard for me to check 130 students' homework each day, so that's your responsibility. Your responsibility is look at my keys, make sure things make sense, and then let me know if you're having issues so I can help you out. I'm going to quickly scan through, make sure that you tried all the problems, kind of look like what we did, but I can't look at everybody's specific answers each day. So do what you can to help yourself out and let me know what I can do to help you. Other than that, you guys, I'm going to show you the homework on my video here, but it's your boy Mr. P. You can pause the video to check out your homework problems. Please do these 4 problems. I'll get it zoomed in here. Again, you can pause and try those out. See you later.